Hello, in this video we're going to be taking a look at section 5.1, which is simplifying algebraic expressions. The main thing to remember about algebraic expressions in this section is that they are not equations. When we're simplifying expressions, there's no equal sign, so you can't actually solve. There's nothing to solve for. You won't end up with just a plain old number as your answer. You're going to end up with another expression. The goal here is to take an expression which starts out pretty ugly and to make it just a little bit less ugly. Let's take a look at the two main tools that we're going to be using for simplifying expressions. We're going to be using combining like terms and the distributive property. First, let's combine like terms. When we say like terms, we're talking about terms that have the same variable and exponent. Most of these won't have exponents at all, but those are the little numbers that you see up top in the upper right-hand corner of a variable. When I say terms here, we think of things that are being separated by plus and minus signs. So in this first example right here, the terms are the 8x, the negative 7y, the negative 10x, and the negative 4y. Like terms have to have the same variable and exponent. If they do have the same variable and exponents, you can add or subtract the coefficients, those numbers in front, and keep the variable the same. So let's see if we can find some like terms in this first example. Well, take a look at that 8x. I'm going to underline that one twice, and I see another variable x here. So the negative 10x is a like term. You'll notice that the sign to the left of the 10, that negative sign, belongs to the 10. So I can take these two like terms, the 8x and the negative 10x, and I can combine them by adding or subtracting. Well, I want to be careful here and pay attention to the signs. 8 minus 10 will give me a negative 2. If you need a bit of help with remembering how to deal with signs when adding or subtracting, go back and revisit section 1.9. So 8 minus 10 is negative 2, and that's going to give me a negative 2x. I keep the same variable, and that's super important. It's often easy to accidentally forget that variable when you're combining like terms. Let's take a look at the other terms I have here. I have a minus 7y, and I also have a minus 4y. Those both have the variable of y in them, so they are indeed like terms, and I can combine them. Again, I'm going to be very careful with my sign rules for adding and subtracting. And they say if two numbers have the same sign, you add them. Well, both these numbers have a negative sign, so I'm going to take my negative 7y and my negative 4y. I'm going to add the values of 7 and 4 to get 11, and I'm going to keep the sign. 7 and 4 gives you 11, and they're both negative, so I keep the negative sign. So it'll be a negative 11, and I'm going to bring the variable down with it, y. And believe it or not, this is my final answer. I can't solve for x or y. I don't know what either of them is because there's no equal sign. This has just taken a very ugly expression and made it a little bit simpler. So right here, I have my final answer. Let's take a look at this next example. I have a lot of different terms here, so I'm going to have to be very careful and pay attention to all of them. I like to just pick a first term to start with. Usually I go in alphabetical order for the variables and try to find all the different terms that have that exact same variable and exponent. So I'll start with the 5a, and I see another term with an a right here. Well, hold on, that a doesn't have a number in front of it. And if you remember from previous sections, if there's no coefficient, if there's no number in front of the variable, you can put a little secret 1 there. There's a 1 hiding out. So that's going to be 5 and minus 1. I'm going to circle both of those just to indicate that I've used them. And 5 minus 1 is going to give me a 4, and I bring the variable of a down. So that gives me my first pair of terms that I combined. And I'm going to look for some more terms here. Well, I see a negative 9b, and let me see if there are any other terms with b's. And if there weren't, I just wouldn't combine it. I would just bring it down. But I do see another term with a b, and it's this plus 8b. Well, if I write that down, negative 9 plus 8. Different signs, so I subtract 8 from 9 and I get 1. And I keep the sign of the bigger number. So since 9 is bigger than 8, I will keep that negative sign. Negative 1b. Now you might be thinking right now, that doesn't seem quite right. You're right, there's something else we have to do here. But we'll get to that in a moment. And let's do our very last pair of terms here. I have a positive 3c. I'll put a little triangle around that one just so that I can have different shapes. And a negative 3c. different signs, so I have to subtract, and 3 minus 3 is 0, c. Now you might think that you just bring down the c since 3 minus 3 is 0, but that's not quite right, and let's talk about why. It's a very common mistake, but it's not quite right. You notice when I had the 5 and the a and I combined them, I put that 1 in front of the a, because if there is no number in front of a variable, you can put a 1 there. And likewise, I have this 1 in front of the b. And if there's a 1 in front of a variable, you don't want to write it in your final answer. So this becomes 4a, that's fine. And it's just minus b. You don't write the 1 as the coefficient if it's there. If there's a 1 in front of a variable, you leave it off. Now what about this plus 0c? I don't want to just get rid of the 0 and bring down the c, because if I bring down the c, that would imply there's one of them. But there's not one c, there's none of them. And if that happens, it just cancels out, so you don't write it at all. In other words, if you see two terms like the plus 3c and the minus c, they have different signs and you subtract them, and they subtract to 0, they cancel out completely and you don't write them in your final answer. My final answer for this one is 4a minus b. So that's the process of combining like terms. Let's take a look at the distributive property. The distributive property comes up when you see parentheses in an expression. A number touching a set of parentheses gets multiplied by each term inside the parentheses. I usually like to use little arrows to indicate this so that I can make sure that I'm multiplying each term. So let's take a look at how this might work. I'm going to take a look at this first example, 5, and then inside the parentheses I have 7x minus 12. There's two terms in there, the 7x and the minus 12. I'm going to take the 5 that's touching the parentheses and understand that when it's touching it means it's multiplied by 7x and then multiplied by the negative 12. And I'll just go ahead and multiply the coefficients. 5 times 7 is 35, and I can just bring down the x. And then 5 times negative 12 is negative 60. Now you'll notice that I'm not just saying bring down the minus sign. I'm actually considering the positive with the 5 and the negative with the 12, and that's important for this next example. Make sure that you use your sign rules for multiplication. A negative times a negative is a positive, but a negative times a positive will remain negative. Same with a positive times a negative. Let's see what happens here. I'm going to take my negative 9, I'm going to multiply it by all three terms inside the parentheses separately, and I'm just going to bring down my answer. Negative 9 times positive 8, a negative times a positive is a negative, and 9 times 8 is 72. I'm going to bring down the x, and that's fine. But now for my next distribution, negative 9 times negative 7y, a negative times a negative will be a positive, and I actually want to write the positive sign. You always want to have signs between terms, a positive or a negative, so I do want to write the plus sign here. Negative times a negative is a positive, and then 9 times 7 is going to give me a 63 here. And I'll bring down my y. And last but not least, this negative 9 times this plus z. Don't forget, if you don't see a number in front of that variable, put the little secret 1 there. And so a negative times a positive will give me a negative, and 9 times 1 is 9. And then bring down your z. So our final answer here is negative 72x plus 63y minus 9z. So to summarize, when you're simplifying expressions for section 5.1, you're not going to get a number as your answer in general. You'll get another expression that's hopefully a little bit simpler and nicer than the one you started out with. A little bit less ugly, I like to think of it as. There are two ways of doing this. Combining like terms means looking for terms that have the same variable and adding or subtracting the coefficients. Distributing means taking the number that's touching the parentheses and multiplying it by each term inside the parentheses.